Hi, everyone. It got a little empty in here. That's good. I'm less nervous. So my name is Michal. I will talk to you today about Semgrep. So first of all, who am I and what do I have to do with Semgrep? So I have nothing to do with Semgrep. My name is Michal Kamensky. I work at Bound Security, and I will talk to you today only about the free open source version of Semgrep. So what is Semgrep? It's a static analysis engine maintained by R2C, a return to corporation, and it basically finds patterns in code. Its name is semantic plus grep, which means it's a text-based search that is aware of the semantics of your source code. So why Semgrep? As part of my job, I had to use various SAST tools. And everybody who has ever used a SAST tool knows that there are some problems with those tools. First of all, there are so many results. Many of them are false positives. I'll just explain quickly what are SAST tools for anyone who is not familiar with them. It's a tool that scans the source code and finds vulnerabilities in it. So all of the times it returns too many results, many of them which are just garbage, and then you have to go through all of them, and it's very tiring. The second problem is it's hard to customize. Companies want to find things that are specific to their source code, and most of the SAST tools don't offer rule customization. So it feels like there has to be a better way. And of course, I'm not the only one who thought that, as you can see by the amount of SAST tool companies. So when I had to use Semgrep for one of our clients that had some specific needs, they wanted something customizable and also fast and easy to use, not too much configuration. So it felt like, okay, there is a better way. And also maybe by the end of this presentation, it will be more clear why it's hard to do it on scale, to do a good SAST tool with a low amount of false positives. So what we'll talk about? The basics of Semgrep, just understand what it is, finding some flow-based vulnerabilities, and looking at interfunction, interfile scanning. Those are the supported languages that Semgrep supports. The first column, GA, is generally available. The other ones are like beta or experimental. And as I said, it finds patterns in source code. And unlike other tools that find patterns, for example, regex, at least I don't come back in the morning and feeling confused, did my cat fell asleep on the keyboard again, or did I write this? He likes to do that from time to time. You can run those rules in the Semgrep playground, which is their name for their web UI, and also in a CLI in the terminal. I will show you examples of both. So what does the rule look like? Each rule has this structure. It has the rule keyword. The ID is the name of the rule. You use this name also to reference it in when you run it in the command line. You have the pattern, which is the main thing in the rule. There are a lot of different patterns you can use. We will look at some of them. There is the message, which can be just simple, like found a match. It can give more information. Language is the language of your source code, and a severity, like a warning or an error, something like that. So here we have just a basic pattern to find a Python print function. It doesn't match any of the other print functions because it's just an exact match. Then if we want to match any print function, we have the ellipsis operator. Ellipsis is just those 3 dots, and then it matches anything. It can match nothing at all, 2 variables, a string, 1 variable, anything in a print function. It never matches comments in the code. Semgrep just ignores them. If you want to specify that you want at least 1 variable and you don't want to match nothing at all, you can use meta variables, which is, it starts with a $sign and then uppercase letters, and it just indicates this is a variable. So it didn't match the function that didn't have any variables at all. And if you want to match a string, you can do just quotes and the ellipsis operator in between. So let's look at this rule. Here we want to find places in our code where we opened a file and didn't close it. So what we do, we tell them to look for a pattern of opening a file. And then we tell them to ignore pattern not inside, that this pattern is not part of a flow that has open and close in the end. Also, an interesting thing here is that Semgrep, if you declare a meta variable, it will only pay attention to if it's the same meta variable here and here. For example, here we have fd open and fd close. If we had fd open and here something else close, it won't ignore it because it's not the same variable. So let's take a look at this. This is the playground of Semgrep. We can run this code, this rule, and it matched the first one, and it didn't match the second one because here it's closed. If it was a different variable here, and we run it, then it would match it again because it knows that the file we opened here is a different file than what we closed here. Another thing we have here is this comments, rule ID, and OK. These are sort of unit tests for our rule that if we have if we say rule ID and the name of a rule, it knows that it should match it. And if we have OK and the name of the rule, it knows it shouldn't match it. So here we have, when we ran it, one of our tests failed because we shouldn't match it when I changed the name of the variable. And when I change it back and run it, all of our tests pass. OK. Got stuck? OK. So let's look at finding secrets that are hard-coded in our code. You can write a rule using Semgrep to find hard-coded secrets. If you have a hard-coded key or hard-coded passwords, it uses this entropy analyzer that if it finds a string that has high randomness, higher than usual English words, it will find them. But what is really interesting, these were just the basics of Semgrep. What's really interesting is things that involve flow. As the previous speaker said, what we're looking for is things that go into a source function, go through some sanitizing, and then come out at the end at some dangerous function, a sync function. So what's really interesting is when we forget to sanitize or sanitize poorly and It just goes straight from a source to a sink. That's what we're interested in. So let's take a look at this path traversal vulnerability. This is from OWASP WebGoat project. We have here a request query string, and then it goes to this map path with a file name with no sanitizing in between. So in order to find that, we have taint mode in Semgrep. Taint mode says that if we specify a source function, that what the output of this function is tainted. So this tainted input goes into this variable file name, and then this file name flows to the sink that we specify, map path, our sink, and then it finds it in the code. And we can put the meta variable also in the message, so it will tell us potential path traversal found, and sanitized input is file name. It will replace it in the message. This is a simple cross-site scripting. Also, we have the request, and it goes to request is our source, and it goes to label output.text, which is our sink with no sanitization. Okay, but what if we do have sanitization? Our previous rule will find, it doesn't matter if we have here in code before the city or not, it still flows there, right? So the rule will find it anyway. We don't want that to happen, so what can we do? In taint mode, we also have, as we have pattern sources and pattern sinks, we also have pattern sanitizers. And here we specify all the functions that can sanitize our input. And here we have HTML in code. It's like a function, that function, it calls it. And we have here HTML in code. So Semgrep won't find it, this instance. It knows it's safe, it ignores it. This whole thing got complicated when I tried to look at this very simple cross-site scripting example from WebGoat. We have here the request, and then we call load city, and here is our sink, and here is fixed load city where we sanitize the input. And I tried various things all day, and nothing worked. Semgrep just didn't find it. I was sure I was doing something wrong because it's really simple. Their taint mode should find it. But here is the rule that I wrote. Here is the code from Semgrep. I run it, and it finds nothing. It failed a test that it should match. It didn't match the test that it should match, but it didn't match anything. So just one piece of advice for me is read the documentation next time. It's more fun to play with it and just try things yourself and just bang your head against the wall, but sometimes it's good to just read the documentation. So apparently the free version of Semgrep doesn't support cross-function flow or cross-function cross-file flow. It just don't know what happens when you go to a different function, what happens when the variable flows into a new function that is defined somewhere else. Semgrep just doesn't follow. So apparently there is something experimental called join mode, where it's not exactly flow tracking like in taint mode, but you can specify 2 rules or more and just get the intersection in between in the way that you define. You can like make a rule for the input, a rule for the output, and tell it to find this the place where it's the same variable that was in the input and in the output. It works kind of the same way like SQL join for anyone who is familiar with that. So here is the input rule. where we have the request and which gets a variable and goes into a sing. Which we have here, a request, and it goes into a sing, which is load city. Then we have the output. Here we check for sanitization, and here we have the function that inside of it, the load city function that inside of it we have the sync with the label.text. And we are joining on where the variable in the input is the same as in the output, which is city. Okay, so what we usually, when do we usually encounter the need to use this join mode? When we have functions that call other functions. So for example, if we have this function 1 that calls function 2, and function 2 calls function 4 calls function 5, etc. So we want to know that function, if we call function 1, we're basically calling in the end function 5. So we have this call graph rule that defines a caller function and a callee function. And Semgrep creates this table with caller functions and callee functions. And he gets to the point that he knows that function 1 eventually calls function 5. So here is our join mode rule for our load city. And we have the caller and the callee, which is our caller is page load and our callee is load city. So this is how we write our join rule. And here inside rules, we'll put the output, input, etc. This here tells Semgrep to create this call graph table. And we tell it to join when the variable in the input equals the variable in the output, and the callee equals the input sync. So that's the entire rule. If we want to see it better, we can just look at it here. This is the rule, and you can't run join rules in the playground of Semgrep because it's an experimental feature. So you need to run it in the CLI. It's very simple, and then here we found our vulnerability. So we went over the basics. We went over finding flows, and eventually got to the inter-function, inter-file scanning. This works also if those functions were defined in different files. It doesn't matter, it's the same thing. So what do I want from you? First of all, to know this exists. Second of all, it's a great open source tool that people can contribute to. You can contribute your own rules that you have written to their GitHub. It's really simple and people can use it. Their open registry has already over 2,500 rules. So what are the advantages of Semgrep? It's very simple, it's very fast, and it's very useful when you use it to scan your own source code in your organization. If you want to look for a certain function that is not safe and you replace it with a different safe function, you want to scan the code to see if anyone is still using this unsafe function, it's very simple. If you want to check that you use some sort of library that your company uses, like my company.authorize or something, it's also very simple to do that with Semgrep. What are the problems with Semgrep? There is no open source cross-function or cross-file flow scanning. This join mode doesn't really track flow. It doesn't remember that a variable is tainted. It's just something that does an intersection of rules. There is a paid feature called Deep Semgrep, but it only supports a limited number of languages, and it's also paid. And also, as I started in the beginning, SAST tools, one of the difficulties they have is they need to be general. They don't use source code. They need to apply to all sorts of source code. And if you want to write rules that apply to all sorts of source code, you will end up with some false positives, because it's either it's too specific and then you miss vulnerabilities, or it's too general and then you have a lot of false positives. But if you write rules for your own repository for your own code, then you can avoid these problems that usual SAST tools have. That's it. Thank you.